tutorial 4 we are going to discuss operation toolbar. In operation toolbars we will see the following commands. First is corner. Second, corner is also named as fillet. Second is chamfer. Third is trim. Fourth, break. The next is quick trim. Then close arc, complement, project 3D elements, intersect 3D elements, project 3D silhouette edges. So these are the commands which we will cover within this operation toolbar. Now let us launch the CATIA V5 and see the changes and see all commands in detail. So here we are in CATIA. Let's launch the mechanical design and then sketcher. Give it a name of operation toolbar and operation toolbar drawing and click on OK button. Here we have YZ plane. Let's take a sketch on YZ plane and let's drag down the operation toolbar. First is corner. Here we have, so for the to draw a corner we need a line segment, so let's draw a horizontal line and another line which is a vertical line. Now to introduce a corner, let's just select the corner and select the first line, select the second line and give the position for the corner or the limit for the corner. So this is our radius. Let's just double click on this and edit the radius. We can also switch between the diameter and the radius from here. Just go to radius, give it a value of 20. This is our corner or fillet defined. Next is our chamfer. Select the chamfer, select first line, select second line, give it a position. So this is our chamfer defined, which is defined by angle and distance. Let's double click on the angle and give it a value of 30 degrees. Second, to change the distance, let's give it 20 distance. So this is a chamfer of 20 by 30 degrees, or you can also change from 20 to 30. Here are some types of the chamfer. Trim all elements, trim first element, no trim, standard line trim, construction line trim, construction line no trim. First was trim all elements. Trim first element, it will trim the first element. As you can see here, my first element has been trimmed but the second is remained as it was. So this is trim first element command type of chamfer. Second, no trim, it will keep the lines as they are. Oops, I think this is the type of second. Let's just again go to the third one. Select the first line, select the second line. Here we can see that nothing has been trimmed and the chamfer is also defined. Just go to chamfer again and next is standard lines trim. Just select both of them and standard lines are kept as they are, but you'll better understand if we make two line segments intersecting to each other and having the extensions also. Here I have two lines. Let's just go again to no trim, select both of the lines, select the position. So this is our no trim type of chamfer which has trimmed nothing. Now let's just again go to chamfer and choose the standard lines trim. Select the first line, second line. So this, as you can see here, has trimmed the extensions. So standard type of chamfer trims the extensions lines. Just go to chamfer. Next is construction line trim. It will create the construction line. As you can see here, it has created two construction lines and trim the extensions. Next is our construction line no trim. So it will create a no trim type of chamfer, and all the lines will be converted into construction line. Next is our trim. Trim command allows us to trim up to an intersection point. Just select the first line and select the lines which you want to trim. So that's a kind of trim. And next is break. Break is used to break a line from a point. So let's just select the break command, select the line, select the point from where you want to break the line. So as you can see, my line has been broken into two parts. You can separately delete the parts or the segments of the line, or operate them as separated parts. Next is quick trim. It is used to trim the extension lines or the extension parts of lines or line segment. Just select the just select the quick trim and just click on the extension which you want to trim. This one, this. As you can see here, all the extensions line can be trimmed, and single line also can be trimmed. So this was our quick trim command. Next is our close arc, which ensures that our arc is closed. So to perform this, let's make an arc, a 3-point arc, and just go to close arc. This is open. If you select this, so this will close your arc and a circle is made. Next command is complement command. Just go to 3-point arc, and this is our one segment of a line or arc. Let's just increase its size. So this is a major segment of arc, and if I click on the complement and select this arc, so this is our minor segment of the arc. So this is called the complement. Now we have a line and a circle segment. Next command is mirror command. Select both of the elements and select the reference elements. This has created a mirror along an axis, about an axis. Next is symmetry. Symmetry is the move. The mirror, and the difference between a mirror and a symmetry is mirror creates the copy, symmetry moves the element. Let's make a circle. Next is translate. Translate is to copy on a distance. Just select the circle, select the center point, give the number of instances to be 10, let's say, and give a value of 100 between two instances. So here we can see there is a single array made, single row made of circles. This is called a translation in 2D. Next command is rotate command. Rotate command makes sure that the instances are copied about a point, about a circular point. Let's make a circle and make another circle on the quadrant point of the previous circle, and just go to rotate, select the object, click on the center point about you want to rotate the model, and let's give a number of instances of 2 and give it degrees of 30, As you can see, the object has been rotated by 30 degrees. Next is a scale. Let's say I have made a circle of 50 degrees, 50 mm radius, and I want to scale this. So to do so, let's just delete these lines. Let's make a rectangle, make a circle, and select the rectangle, click on the corner point. As you can see here, another rectangle is being projected. Give a value of scale factor to be 2. So as you can see here, this is my original rectangle, and the bigger rectangle is the scaled rectangle. Next is offset. Offset creates the object parallel having an offset distance. Click on the offset, click on the object which you want to make offset of. So as you can see here, each and every line has been created at an offset distance of the rectangle which is parallel. Here we have some types of offset, like point offset, propagate offset. Just click on the object and all lines are automatically created at an offset distance. Next type is both side offset. Both side offset is for bilateral offset. It means it's no longer unilateral. It's being created on both sides of the objects. So these were all types of offset. Let's just make a circle and make an offset of a circle. Just click on the circle, so you can see a circle has been offsetted on both sides of the original circle. Now let's change the distance to be 2. Second is automatically changed, which is connected to the previous one. Let's give a constraint between them to be 1, but it can't change. Okay, let's just take the sketch on YZ plane and make a line segment. Let's take a plane parallel to XY plane, which is the top plane, and give it an offset distance of 20 mm. So this is a reference plane created parallel to the top plane. Now let's just take a sketch on this plane. Let's create a rectangle. Let's get out of this sketch, create a pad of this profile, give it a distance of 2 mm. So this is what I have created, and let's have a sketch on the top plane, XY plane, that is XY plane, and this is our project 3D elements. Click on the project 3D elements. Let's rotate it so that you can better understand and see the effects. Click on the 3D element, click on the edges which you want to project. So as you can see here, I took the sketch on the top plane and I'm going to project the edges of this box, and those edges are automatically being traced on the plane on which I took the sketch. So you can see here, this is my, let's have another plane parallel to the top plane. This time I'm going to take a offset distance of 2 mm, and let's take this sketch on this plane which I defined, and let's make a circular entity this time. I'm going to pad this. Let's reverse the direction and give it a distance of 20 so that my plane should be inside the object. Let's go to YZ plane and take a sketch on this. Let's make a line along the horizontal axis passing through the origin, and this is my line, and I'm going to switch in the wireframe and surface workbench. Let's create the surface extrude up to a distance of 3 mm on mirror extend. So this is total 6 mm I have extruded. Now let's again get back to sketch. Let's get back to part design, and so next is you want to intersect between I have taken the sketch on the surface, and I'm going to select the objects which are intersecting to each other. As you can see here, this circle is intersecting, this cylinder is intersected, leaving a circular profile. Let's define another plane parallel to XY, again having an offset of 5 mm this time, and let's just delete this. I'm not going to define. I'm going to take a sketch on the ZX plane, and let's make a circle and pad it. Let's make a pad, give it a distance of 5. So this is my circle, and this time I'm gonna take a sketch on the top plane, which is a ZX, so the XY plane actually, and this time I'm going to project the 3D element. Click on the OK. So as I selected the circular face or circular part of the cylinder, the edges have been projected, so this is called the similarity. Here I'm going to conclude this tutorial 4, and I'm going to conclude tutorial 4. Thanks for watching the video tutorials from CAD Desk head office. Stay tuned.